Given an integer array num sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. Non-decreasing order, I'm not sure why they worded it like that. Non-decreasing means increasing. In example, we've got nums, and and the output is going to be each number squared and then sorted. So -4 squared is 16, but it's not the first number of the new array because 16 is greater than 0 squared. And that's what the explanation is saying. After squaring, the array looks like this. 16 is first, but then after sorting, it looks like this. And then same thing for this example. Constraints, nums is always going to have at least one number, but then the number, and then the nums array is always going to be less than, the length will be less than however many numbers that is. And then nums is sorted in non-decreasing order. So those are the rules of this one. So I can write this out. Rules would be the input is always sorted in non-decreasing order, and the output, let's say input is sorted in non-decreasing, and then output is, like they say up here, squares of each number sorted in non-descending order and increasing order. Okay. And so those are the inputs and outputs we want, and to get that happening, the steps we could take would be to, we know we're going to have to return a new array, so let's declare new array, a new squared and sorted array. Like it's going to be the same length as the original, but just squared and sorted. So now to go about sorting or squaring and sorting, we'll have to look at the original array, and we already know it's sorted in increasing order. So if we were to look at the first iteration, we know we have to iterate through the array at least once to see all the numbers. So if we looked at the first and last number, we could compare those two, point at them both and say which one's bigger after it's squared. 10 is bigger squared, so 10 squared is 100, -4 squared is 16, so 100 is going to go to the end of this new list because we're trying to sort it from least to greatest. And then if we looked at the next biggest number from the right, because 10 is already done, so 3 squared compared to -4 squared, -4 squared is bigger, 16, so let's add it to the second last. And we go like that for each number. And then, so now if -4 is done, now we're looking at -1 and 3, so 3 is bigger, so it goes like that. So we need to declare left and right pointer, and then we need to iterate nums on each iteration, set new array current index to greatest between left and right squared. Yeah. And then at the end, and then also if left is greater, increase left pointer. If right is greater, decrease right pointer. And then at the end, we would want to return new array. And in code, this is going to look like squared and sorted list is going to be a list of the same length as the original, so length of nums, and then we need a left and right pointer. Left pointer equals the first index, the right pointer is the last index of nums, so length of nums, last index, not the last element. And so our step 3 is iterate for each index in the range of indexes of nums we want to start from the right, go all the way to the first index, and going from right to left. And this is the way to do that. Range, length, nums, and range takes in some arguments, like where are we starting, where are we ending, and then how many, what's the distance, how many time, like how far are we going for each iteration. And so we're saying if the absolute value of nums at the left pointer index, if that's greater than the absolute value of the right one, nums at the right pointer, and we know we already talked about the first iteration, it would be -4 versus 10. -4 is not bigger. So in that case, we'll want to use the 10 and say this squared sorted list, get that last index, which we're currently at, and say its last index equals the nums at the right pointer, 10 squared. So we have to say the right pointer squared. And then on the next iteration, or on the next iteration, like we saw, -4 is going to be greater than 3 again, but then -1 is less than 3. So in that case, we'll do the same kind of thing, but instead of setting it to the right pointer, we're setting it to the left pointer. And then on each time that happens, we want to change which pointer we're looking at now. So the pointer is going to increase by 1 if it's the left, and it's going to decrease by 1 if it's the right, because we're going from right to left and from the left side left to right. So -1. And at the end, we can return the squared and sorted list that we've been making this whole throughout each iteration. And that is our answer. Squared and sorted list index is out of range. Oh, we had to, for the range, we have to say -1 because we're talking about the index and not the last element. So that is the answer. And we can talk about now the complexity. So the complexity is going to be O of n time, because we're iterating through the whole list once, and on each iteration we're making constant operations, so it's time. And then the space would be O of n space, because this array that we made at the beginning is the same length as our input array, so that's taking up O of n space, and everything else is a constant space. So the benefit of this, like the pros and cons of this, is that it's the most optimal we can get, like we're doing O of n time and O of n space. But the downside is that it might be a lot to look at, like it's kind of might be complicated to look at. So another solution we could do is, instead of doing all of this, we can just return an array that's been squared for each number for num in nums, and then after everything's squared, it's sorted. So we sort everything. So we just squared all the numbers, sort them all, and return that. So this could be another answer. The pros of this is it's very short and sweet. It's easy to look at. But the downside is that it takes more time, because we're having to iterate through the whole array one time, and then iterate it through again with the sorted method, which makes it O of n log of n time. But then the space should be the same. That's all there is to this problem. If you have any questions, let me know. I'll be happy to answer in the comments.